Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 9 of lesson number 10, Gravitation. So, in the last class, we started about pressure that has been exerted in fluids, right? We discussed on that, and there was an example and activity as well that we discussed with respect to it to make it easier for us, and we even discussed on buoyancy, right? So we are just left with few part now to end up with the lesson. Like we are left with Archimedes principle, then we have relative density, and there's one more concept that we are going to study, and that is how, like, after that we will be having like 22 questions to discuss at the end for the lesson, right? So as you all know that before we start the lesson, we always make sure that we are revising each and everything that we studied before, because like I have this thing in my I have learned this thing, like whatever, whenever you go ahead in your life, like don't forget your past. Now past is with respect to the lesson. So when you're moving ahead with the lesson, don't forget whatever you have studied before. Otherwise it will be like one concept today and tomorrow you're forgetting it again. So that is going to create a problem for you, and it will be a complete chaos for you again, right? Because you'll have to again sit with the lesson during your exam, then rectify it, and rectifying it means like after you are done with the exam you won't even remember what you have studied, right? So make sure you're not doing. I don't want each, like, any of my student to do that, because I just hate, like, students rectifying the concepts. Okay, so now before I proceed with this part, I want each one of you to please revise whatever you have studied so far in the lesson. I hope every one of you are going through the notes that you have taken. And I hope you all have started revising it. So we started the lesson by discussing on gravitation in detail, right? So I just want you all to please go through this slide. I hope you all are going through this slide. Like if you have to write about what we have studied before, about gravitation, this is what you all are going to include, right? So please go through it, everyone. After gravitation, we discussed on this activity, which is the most simplest activity, I guess, right? So after this activity, we discussed on the universal law of gravitation, where we get the formula like F is equal to capital G, then product of their masses upon distance square, right? So F, that is force, is equal to gravitational constant, then product of their masses. So capital M is the mass of object A, small m is the mass of object B, upon d square is the distance square, right? So how we got the formula, like we also discussed on that, right? So that is there on the next slide. We will be discussing on that as well. But before that, please go through the slide, everyone. So sorry. So this is how we have derived the equation for like universal law of constant. See, you like I have told you in every part that you can get a direct question to derive this universal law of gravitation. So at that time you need to explain this very properly along with the units that we use, along with the value of the universal constant. You can even get that as objective. Okay. So each and every step should be clear to you. After this, we discussed on like who exactly Sir Isaac Newton was and what he was exactly doing, right? So I just want you all to please go through it as well. So here we have more inventions that Newton did, right? So please go through this, everyone, as well. Then we discussed on an example for the same. So I just want you all to please go through it, everyone. I hope you all are going through it and like you have understood it properly how you have to calculate the things that have been mentioned, right? Like before that, before you start solving it, you have to understand the question properly, like what exactly has been given and what you need to find out. And then based on the given information and what you need to find out, you have to come up with the formula that you need to use. Getting it? So that is how you'll come to know like what exactly needs to be done. Okay? Because like I know many of the students they get confused on like how to know that this formula, like we need to apply only this formula itself. So you come to know that because of the, you can say, because of the given information that you have. Okay, so that is what is very important, you understanding the question first, then like looking at what has been given and what you need to find out, and then coming up with the formula based on that. Because uh, once you understand that, you'll even come to know what steps you need to apply, and like you have to do it. Getting it? After this, we discussed on the importance of universal law of gravitation. So I want you all to please go through it quickly. After this, we discussed on free fall, but the proper explanation for free fall is on this slide. So please go through this as well, everyone. After this, we discussed on how to derive acceleration due to gravity, that is small g, right? So the formula for small g is equal to capital G, that is gravitational constant, then m is mass upon radius square, that is r. Okay, r square. Then here also we have the we also have the thing how to calculate the value of the g which has been given, right? So please go through this slide as well, as this is also equally very important. Then we discussed on like motion of objects under the influence of gravitational force of the earth. So here we have the explanation along with the three different equations which have been given. So please go through this as well, everyone. Then we discussed on this example 10.2 as well, and there's one more example that we had discussed, right? So I want each one of you to please go through it quickly. Now all the examples given are very important for you all, and the reason behind is because like you might have seen all the questions, right? I show you all the questions when I end up with the lesson, so you know that you have to do it, right? So it's it will be good for you if you know how to come up with the formula, how to do the calculation part, everything. Okay. I hope every one of you are going through it. After this, like we had one more example over here. So over here we calculated the velocity with which the object was like moving upward, and the second thing we calculated was the time taken by the object to reach the highest point, right? So I want each one of you to please go through the slide go through this example as well, as this is also very important. Then we discussed on mass and weight. So I just want you all to please go through it as well. After this, we discussed on weight. So like we have more information on weight where we have the SI unit and everything which has been given on this slide. So I just want each one of you to please go through it. After this, we discussed on like weight of an object on moon, what exactly it's going to be, and for that you should be knowing the mass of the earth and mass and radius of the earth and the moon. Okay, so I want each one of you to please go through the slide as well. Then here is an example to calculate the weight of the earth. So please go through it, everyone, as well. After this, we have one more example over here. So I want you all to go through this as well, everyone. Then after this, we discussed on thrust and pressure, and I hope you all are going through it.
Sudah. Sudah. Sudah.
क्या हुआ नन्नू? क्या हुआ नन्नू? नन्नू, 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 गलत होगा ना? तुम नन्नू, पूछो नन्नू, नन्नू, And I want you all to please go through it as well. So now we need to discuss on like why objects float or sink on when placed on the surface of water. So we have an activity for that. See, take a beaker filled with water and take an iron nail and place it on the surface of the water. Okay, then after that we need to observe what happens. So what do you think, what will happen like when you observe it, when we are going to observe it? The nail will sink, and that sink will be because of the force due to the gravitational attraction of the earth on the iron nail. So the gravitation is going to pull the iron nail downward, and there will be an upthrust of water on the nail as well. So that upthrust is going to like push it upward, but the downward force acting on the nail is greater than the upthrust of the water, because of which it will sink. Getting it? So therefore, object of density less than that of liquid floats on liquid, and the object of density greater than that of liquid will sink in the liquid. So like you should be aware of this concept. Okay. Okay, so now we have an activity which is like explaining us the same. What we need to do is take a beaker filled with water, then take a piece of cork and a nail iron of equal mass, place them on the surface of water and observe what happens. So what do you think what will happen when you observe it? So you will find out that the cork will float while the nail will sink. What will happen? The cork will float while the nail will sink, and this happens because of the difference in their density. Why does it happens? Because of the difference in their densities, because we know that density is defined as mass per unit volume, right? The formula for density is mass upon volume. So because the density of cork is less than the density of water, it will like the cork floats while the nail will sink. Okay, so this means that the upthrust of water on the cork is greater than the weight of the cork, because of which it floats. Getting it? Why does it floats? Because the upthrust of water on the cork will be greater than the weight of the cork. Okay, so the density of an iron nail is more than the density of water. This means that the upthrust of water on the iron nail is less than the weight of the nail. So that is the reason it will sink. So you need to know the reason why exactly they sink. Okay, and therefore what we can conclude at the end is object of density less than that of the liquid will float on the liquid, and the object of density which is greater than that of the liquid, they are going to sink in the liquid. Getting it, everyone? So I just want you all to take a note of it. I hope you all have written all the points. Now, Archimedes principle, I'm not going to start with it today because this is an important concept. So Archimedes principle will discuss in the next class along with the activity in detail. We will be even discussing on who Archimedes exactly is, and then we have like relative density to discuss. We'll be discussing on that as well. Okay. So after relative density, we have the summary discussion to discuss in detail. We will be doing on that as well. And after the summary, we have like 22 exercise questions to discuss. We'll be discussing on that as well. Okay. So we have altogether like 22 questions that we will be discussing. So this is the last question that we will be discussing at the end of the lesson, that is end of gravitation. And I hope like whatever we a small topic that we discussed today in short, every one of you are clear with it. Okay, so now the rest of the part for the lesson, I'm going to continue with that in the next class. Like we are just left with two more parts, that is Archimedes principle and relative density, and then we have like 22 questions to discuss. So we'll be doing them all, and that is how we will be ending up with the lesson. Okay, so I want you all to keep on revising and studying each and everything that has been done so far. Okay, so I'll end up this part over here. Thank you everyone.